Okay, this is your second question, and on this particular linear relation, I'm not giving you the graph, nor am I giving you the equation, but what I am giving you is a table of values and asking to graph it and find the equation. So the first thing I'm going to do is I'm going to look at my x column when I graph it, and I notice that it goes up by 5s each time, which is really nice. So you could go 5, 10, 15, 20. That's possible. That's fine if you wanted to do that. You could also, if you wanted to, go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's possible as well. But since it doesn't really matter, and since it's probably easiest to simply go 5, 10, 15, that's what I'm going to do on my, and I'll even put 20 here, on my x-axis. So my x-axis is now spaced by 5s, and that's okay because everything is equal in space. But when I look at my y-axis, I can't do this. I can't do 30, 50, and 70. And the reason why is between here and here, that distance is 30. And that same distance from here to here would be 20. So what I have to do is I have to choose. Well, I can do that as well, but I'm going to choose a unit of measurement that works for that y-axis. And in this case, to go from 30 to 70, if I make this 10, 20, 30, 40, 50, 60, 70, I can fit all of what I need to fit on that y-axis like that. But you could also, instead of doing it that way, you could also have done it this way. You could say, I'm going to put a squiggly line here and then go 30, 50, 70, 90. So what you're saying is you're omitting 10 and 20 from that line. Okay, that's a possibility as well. But since my numbers are now outrageous, I am simply going to go 10, 20, 30, 40, 50, 60, 70, 80, 90. I'm going to go by 10s. All right? And I'm going to label, each, I'm not going to label all of them. I'm going to label every second one. Okay, I don't have to label every one, I just have to label every second one. So my first pair, 5, 30, is actually as an ordered pair, 5 for the x, 30 for the y, so it's 530, which as a point will be right here, 530. My 1050, which will be a 1050, is right here. And my 1570 is right there. And when I plot those 3 points, I end up making a line. So I know that the relationship between these points on this table of values is more than likely linear, because those three, or is linear, because those 3 lines when graphed make a line. So this next thing we need to do is find the equation. And again, x equals y. We're going to find our coefficient, and our coefficient of our x value. The coefficient of x is equal to the difference in y divided by the difference in x. The difference in y is 20. So I'm going to put that up top there, the difference in y. The difference in x is 5. So that goes right here. And 20 divided by 5 is 4. So therefore, 4 is the coefficient in the relationship between x and y, multiplying the x value by the 4. Once we have that, we can take any ordered pair. We'll take 5 and 30, and we substitute it into our equation. So 5 is the x value, which does not make 45. It makes 4 times 5. And the y is 30. And since 20 does not equal 30, a plus 10 constant is required to balance the 2 sides. And therefore, all of the points on that line, any point, will fall into the equation of 4 multiplied by the x value plus 10 equals the y value. And real quick, just to show you that that's roughly true, if I made x 7, so 7 would be roughly right there on the y value. If I made x 7, I'll erase this line here, but if this is x is 7, so let's just substitute that into my equation. So x is 7, so 4 times 7 plus 10 will equal the y value. That'll be 28 plus 10. My y value should be 38. And if I go over here, does that look like 38 to you? Yes, because this line here is 40, isn't it? And that point on the y-axis is just going to be just below 40, which 38 seems reasonable. And I can actually even go extend this well beyond that and say if x was 20, what would the corresponding y value be? And the corresponding y value would be 90. And if I go over here, when x is 20, y is also 90 if I extend that line.